So welcome back to class. So this is your B.Sc 6th SEM continued part of your partial differential equation. So in the previous class we studied the non-linear partial differential equations. What is meant by the non-linear partial differential equation and how to get the solution of the non-linear partial differential equation. And in this class we are going to study your first type of non-linear partial differential equation. Okay, and what is the working method to get the solution for such the first type of the non-linear partial differential equation? Yes, so here we have the first type. It is the non-linear PDE in the form of f of p comma q is equal to be 0. So it is mean that the given partial differential equation which is non-linear and it does not contain your x, y and z variable. So means there is absence of dependent and independent variables. Okay, so now this is one method, one type of your non-linear partial differential equation. So let's understand how to solve such the non-linear partial differential equation. So solve means we are getting the solution for that the non-linear partial differential equation. Okay, so it is the method. So what is the method here we have? The method we are going to study. So let's consider this equation first. F of p comma q is equals to 0. So consider this as an equation. It is 1. So now next, so I will consider the equation. So means the solution of this equation as. So let's assume that z equal to be ax plus by plus c is the solution of this equation. Well, so we considered this equation is the solution of this equation. Let's assume that. So means when you integrate, you get this equation. When you differentiate, you can get this equation. Okay. So now I will differentiate this equation with respect to x and y with the partial. So means we get dou z by dou x is equals to be it is a and dou z by dou y is equal to it is b. So we know that usually we denote p as in dou z by dou x and q as dou z by dou y. So ultimately we get p is equal to a and q equal to it is b. Yes. So now substitute these two values in the equation 1. So if you substitute these two values in equation 1, what we get? So we get here f of a comma b is equal to here 0. Yes. So now I will write this equation in terms of b or in terms of a. So when you write in terms of b, it will become as in b is equal to be some f of a. So now substitute this value in the equation 2, so you can get the complete solution. So means it is z equal to it is ax plus by plus c. So means you are substituting the value of b here. b it is f of a into y plus c. So this is what the complete solution. This is what your complete solution, because there are only two variables are present, means the independent variables, and there are only two arbitrary constants are there. So means the complete solution is 1. How many arbitrary constants are present in the given equation? That many of the variables, independent variables are present there. So this is what the complete solution. Yes, if you convert this c in terms of your a only, so that will become the general solution of the given partial differential equation. Suppose you eliminate this a and c from this equation, so then it will be converted as your singular solution of the differential equation. Okay, so this is what we are how to get the complete solution of the given partial differential equation in the form it is f of p comma q equal to be 0. So let's understand how to solve the examples on such method. Okay, so let's do it. So note of this point. So now let us solve some examples on your first type of f of p comma q is equal to 0. So now let's consider some examples here. So here the first example it is p into q is equal to 1. So here we have second example p square plus q square equal to n square, 3p square equal to q and p square plus q square equal to npq. So these are some different forms of examples in the format of type 1 here. So let's understand to solve these examples. Okay. So now note down this example and solve it one by one here. Yes. So now, so this is our first example here. So I will consider P into Q is equal to 1 as equation here. We have 1. Yes. So let's consider. We know that. What is that? We know that solution of equation 1. Solution of equation 1. It is z equal to it is ax plus by plus c. Okay. So this is whatever the solution of this equation is. So now what we have to do? So here when you differentiate this equation by this equation with respect to x and y, you will get. So means what are we doing here? We are differentiating with respect to x and y as a partial. We are differentiating here. Okay. When you differentiate, you can get here p is equal to a and q equal to it is b. So now substitute these two values in this equation. Yes. So what we'll get? So you will get here. So p into q means from equation 1. From equation 1. So equation 1, what is that? It is in the format of p into q is equal to 1 here. So now substitute the value of p and q. So p it is a and q it is b. So therefore I can write this as a p is equal to it is 1 by a. So now from equation 2 we have yes. So equation 2, what is that? Z equal to b is ax plus by plus c. So now here z equal to ax, but what is the value of b? B it is 1 by a into y plus c. So this will provide the complete equation. Otherwise we can say that it is the complete integral. It is complete integral. Okay. So note down this point here. Yes. So let's solve example number 2 it is. So now I will call this equation as an 1. Okay. So equation, I will consider this as an equation 1 here. So now, so the solution of equation 1 is, what is that? It is z equal to b ax plus by plus c. So this is whatever the solution of this equation 1 it is. So means if you are considering f of p comma q is equal to 0, if the given PDE it is in the format, then it is your solution will be in this format only. Okay, definitely it is in the format of. So now let's consider here. So after differentiate with respect to x and y partially. Yes. Differentiate this equation x and y with respect to x and y as a partially, then you get after differentiation p equal to a and q equal to it is b. So now substitute these two values in the equation 1 here. So substitute the value. So what will happen? So from equation 1 we have, so equation 1 it is p square plus q square equal to it is n square. Yes. So now substitute p value. P it is a square and q it is b, it is p square, it is n square. Otherwise you can write b is equal to b. It is n square minus a square, it is under root value it is. Okay. So this is what your b value. Yes. So now substitute this b value in this equation. So this will become as a z equal to b, it is ax plus by plus c, and z equal to a x plus b, it is under root of b square minus a square into y plus c. So this is whatever the complete integral is. It is whatever the complete integral. It is the complete integral it is. Okay. So note down this example here. So let's go for another example we have here. So let's solve another example here. Example number 4. P square plus Q square equal to N into P into Q it is. So let's solve this example. So I will write this equation at here. So this will become we'll write this as an equation here. It is P square plus Q square equal to be N into PQ. So call this equation as 1. So call this equation as 1 here. So now solution. What is that? The solution of equation 1. Solution of equation 1. It is in the format of z equal to be ax plus by plus c. Okay. So this will be your solution here. So now differentiate this equation. Differentiate with respect to x and y as a partially, then you get p is equal to a and it will be equal to this b here. So now substitute these p and q in the equation 1. So equation 1. So means from equation 1 we get or we have so a square plus b square is equal to be n into a into it is b. So now look at here. We want here the value of b, otherwise value of a. So means convert any one constant in another constant. Okay. But here whenever do we are express b in terms of completely a. Otherwise a in completely b. Yes. So for that I will make here. Yes. So how to understand this format? So I will write this equation in the format of b square minus n into ab plus a square is equal to it is 0. Yes, what is that? So I taken n into ab, in this side it will become a minus. So b square minus n into ab plus a square is equal to 0. So now I will consider this equation as a quadratic equation in the variable b here. What is that? So in the equation, so this equation will be the quadratic equation in the variable b, where treating a as a constant. A and n are both are constant here. So now I will write. So what I will write here? So I will write here the equation. So means here. So look at here. So we have the formula. What is that? B is equal to b. I will write here b is equal to b. Yes. So minus a. So minus it is b. So means minus of n into ab plus r minus under root of b square plus r minus under root of b square. Sorry, here we have to consider only a. Okay, so plus r minus it is n minus n of a square minus 4 into a c. So 4a into c. Here we have 4a square. So divided by it is 2 into a. It is a is 1 here. Okay, we have the formula minus b plus r minus root of b square minus 4ac divided by it is 2a. So if I consider this equation as an b square minus n into a into b plus c square plus a square equal to 0 as a quadratic equation, then it will be provided in this way here. So now solve this equation. So b is equal to it is n into a plus r minus under root of n square a square minus 4 into a square. So divided by it is 2b here. So therefore the value of b. So value of b is equal to b. It is n into a plus r minus take a square as a common and take outside. So it will become as a into n square minus 4 divided by it is 2. So this is what the value of b here. So now look at here. Sometimes your value will be not value of b or value of with a will not come that much of easily. You have to follow some rules here. Otherwise you have to use your algebraic formulas. Okay. So now this is what your value b here. So now substitute this b in this equation. So means from equation 2 we get, so what we get here, z equal to b it is ax plus b it is n into a plus r minus a into root of n square minus 4, okay, n square minus 4 divided by 2a into y plus c. So this is what the complete integral, or we can say that the complete solution, or the complete integral complete integral of your equation 1. So means इस equation का ये complete integral और complete solution हो जाएगा. Okay. So write in this example. So let's solve example number 3. So there is I given another example, but solve that example. I will solve this example for you. Okay, as an example number it is 3 here. So now consider this equation as a 1. So consider this equation as a 1 here. So solution of equation 1. Solution of equation 1, it is z equal to ax plus by plus c. So call this equation as a 2. Differentiate with respect to x and y partially. Differentiate this equation with respect to x and y as a partially. Then you get, so p is equal to, it is a, and q is equal to, it is b here. So now substitute this value in this equation. So from equation 1 we get, from equation 1 we get a plus b is equal to a into, it is b here. Yes. So now I will take this b to this side. So this will become as an a is equal to ab minus b here. Yes. So now I will consider b as a common from both the factor. So therefore a is equal to b into bracket a minus 1 here. So after that you will get your value of the b. It is b is equal to a divided by a minus 1. So now substitute this equation in the equation 2 here. So from equation 2 we get, so what we get here, it will become as an z equal to ax plus b. b it is a divided by a minus 1 into y plus c. So this will become your the complete integral. This is whatever the complete integral of your equation 1 it is. Okay. So note down this all the point. So let's solve another example. Example number 5. Q is equals to e raised to minus p divided by alpha, where alpha is any constant here. So I will call this equation as a 1 here. We'll call this equation as 1. So now the solution of equation 1, it is given by z equal to ax plus by plus c. Yes, so call this equation as 2. So now differentiate this equation. So differentiate with respect to x and y. With respect to x and y here. So after differentiation we get p is equal to a and q is equal to, it is b here. Okay. So now substitute this value in this equation. So what will you get? From equation 1 we get, it is b is equal to e raised to minus a divided by, it is alpha. It is clearly your variables, sorry, means given the constant b, it is in terms of a here. So now substitute this value in the equation 2. So in the equation 2 substitute here. From equation 2 we get, here, so this will become as an z equal to be a in ax plus e raised to minus a divided by alpha into y plus c. So this will become your the complete integral. It is whatever the complete integral. It is whatever the complete integral it is. Okay. So note down this example also. So let's move on. The another type of your non-linear partial differential equation it is. Okay. So note down this example.